This podcast is supported by Siemens, your partner for industrial-grade AI.
Hey, it's me, Robert. Before we get started with Peter and his AI agents, I have an important announcement. Our friend Professor Dr. Marco Huber is hosting an AI conference next week on 14th of November. He still has a few tickets available. Rich Walker and Frank Hutter, among others, will be there. And we will be there too. So don't miss out. Details are in the show notes. And now, Peter, the stage is yours.
Hi there. Welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg and I'm your host. And today I'm going to be talking to Christian Gilcher. He is founding managing partner of Embraceable AI. And Christian and I are going to talk about Agentic Process Automation. Hi, Christian.
Yes, hi, Peter. Thanks for having me.
You're welcome. Please introduce yourself to our listeners.
Yes, my name is Christian Gilcher. I'm founder and CEO of Embraceable Technology, which is the company behind Embraceable AI. I've had around 10 years career in investment banking IT, where I've at the end headed the IT business management department, including the responsibility for the IT budget, but also for IT processes and process controls. So basically the whole compliance space. And at some point I decided that I would like to change sides, so to say, which is to leave the corporate environment and basically start building something on my own, so to say, in order to do a couple of things slightly better than the stuff I found when I was responsible for just getting things under control in the investment bank.
Okay. Yeah, that's interesting whereabouts, investment banking. Not sure. I don't believe we had before a person on the Industrial AI podcast with a history of investment banking, but that should make us even more interested in what it is that you're going to tell us today. So why not for a start? What is APA? Is that how you call it? Agentic Process Automation?
Yes, exactly. Agentic Process Automation. It is basically a new approach to, let's say, business process automation. We know things like RPA, robotic process automation. That's been around for quite a while. But that RPA, as we know it, has a few limitations, particularly when it comes to complex processes or let's say complex rules or policies and compliance rules that are to be considered. And that existing approach to automation, that requires a lot of manual translation work, so to say. So, which is when you set up this RPA, you often run into limitations in terms of it's too cost expensive, particularly for these complex processes. Or when you operate in regulated spaces, some of these regulations change pretty often. So you would have to, let's say, reconfigure that RPA space every now and then, which requires people to do it, basically. So it's a capacity problem. And even if you've got capacity, it suddenly becomes a cost problem. And basically, APA, Agentic Process Automation, is looking to overcome these hurdles or these limitations by using large language models as an, let's say, interpretation engine for these, let's say, complex rules and policies. So it becomes a lot easier from a setup and maintenance perspective to run these sort of complex processes that every now and then pop up when you look at regulations in all regulated industries. Regulations become more rigid. They become a lot deeper, so to say, and they become adopted to more and more business processes. Yeah? So this kind of traditional RPA becomes more and more limited, if you want. And that's basically what APA is looking to, let's say, overcome or to facilitate. Now, from a what is it in reality and how can you imagine? Maybe when I'm being asked, it always helps to say what is an agent or what is agent as such and what is multi-agent systems and how can you think of it?
And I'm going to ask you to explain that in a moment. I want to just very quickly stand still with these three acronyms, if I may, because I wasn't sure I was thinking about it in that way until now. A BPA, business process automation, I have not been involved in. I assume that's typically what you've been doing in the investment banking. Now, RPA, the robotic version, I did write a book. I wrote one with Robert and I did one myself a couple of years back. And I did even have, I believe there's one question about RPA there. But, and you remind me, I have not seen really RPA, robotic process automation, but that is maybe because I've not been concentrating on it, and we'll hear that from you later. And then you give the next one is the APA. So now we move from the business to the robotic to the agentic APA. Yeah. So sorry for interrupting there. I think maybe you were going to kind of explain. Maybe you can give us a couple of use case examples in specific different customer market segments to get a better idea of what exactly APA is?
Yeah, certainly. So maybe just to give you kind of a picture in terms of how can you think of APA, it's like a single agent, an AI agent is pretty much like a single person that is specialized in a particular field, right? So maybe you have like a single person that is specialized in taxation law, for example. And maybe you have another person in the company that is specialized on, I don't know, regulation for health, the health sector, whatever. So there is a group of people who is specialized in knowledge, and maybe there is another group of people in your company that's specialized on doing things. You maybe got a specialist for CRM, or you get a specialist for solving complex mathematical formulas or something else. And APA basically is a multi-agent approach. So you can think of like you put a group of people in a room, group of people that are specialized in these particular tasks. You put them in a room, you lock that room up, so to say, and you hand them some tasks into that room. And you've got this group of people solve that particular task for you and give the answer back out of the room. And basically, this is how APA works from a business perspective. It's pretty much like what we had a couple of years back, business process outsourcing, where you basically, took whole processes and basically gave that out to a professional services provider. BPO never quite worked because we always had this knowledge gap in between. But agentic process automation pretty much works like digital BPO, so to say, which effectively is kind of an end-to-end automation for particular business processes. And I can give you an example, maybe for the retail and e-commerce industry. It's just your typical customer complaint process, where typically in the old days, you've had kind of a script-based, if this, then that approach. But clearly you can have hundreds, thousands of different variations of this process. And in the old days, you would have to define each and single variation of that process, including like if this, then that rules in between. So with agentic process automation, you can configure, let's say, these specialized agents. You can define group of agents or types of agents that you would need. And then you define a group of agents. So you define those collaboration rules that these agents should adhere to. And basically you can hand in like customer complaints. You just give them the input and let the agentic system figure out the best solution.
Okay, sounds good. By the way, do you prefer talking about agentic, or is that part of the acronym APA, or agents? You use them one way or the other?
Well, yes. I mean, agents are the single, let's say, the single workers, yeah? Mm-hmm. And this is like the single specialist human in that group of people. And agentic as such just means this automation approach. And agentic typically includes a group of agents. So it's a bit, it's synonym in part, but the agent as such is, let's say, is the single atom. And the agentic is describing more the approach.
Yeah, some listeners may recall there was this point when Andrew Wang, it must have been a couple of months back, where he was having a discussion about difference or not. I mean, in the end, they are the same, of course, but more the verb agentic in relation to agents. Yeah, and I think he was saying that agentic sounded to him more serious, maybe, I believe. So maybe the term agents had been used or misused. And I must say, we actually did have depending on when we're going to air our podcast from today, but let's say a week or some weeks back, there was a very specific case that I did share. I actually recorded it with Robert only a couple of days back. And it was about a spare parts request coming in, maybe very similar to what you just said is in a retail environment. But in our case, it was like an industrial environment, spare part. And there was this example. And that's also where typically isn't maybe in the English American language is the person that sits on the phone today, where maybe in the future there's a chatbot or it's agentic. They are typically being called agents. Not sure what is the word that we use in our case. We're both from live in Germany, but maybe that's the reason why, because so humans in certain service functions are being called agents as well, right?
Yes, absolutely. It's pretty much, it's a good example because typically in that customer service center environment, this first level, second level, third level approach. And it's pretty much like, it's the same idea. You've got specialized people sitting, let's say, in different places. And the first level operator who's basically just accepting the incoming, let's say, the business request is just, you know how to say, it's orchestrating. He's just kind of classifying in his brain to say, is that a complaint or is that a spare part request or what is it? And unconsciously, I mean, the human brain works like this. Unconsciously, he says, okay, now this is this type of process. So I need to pass that on to this specialist XYZ. And that's pretty much what this agentic process automation, pretty much when you get this incoming request, the first thing that the system does is like a dynamic planning, basically kind of categorization. Depending on that categorization, the system dynamically creates a plan particular for that case, how to solve, what the specific steps are to solve that case. And it kind of autonomously runs through these single steps. So it's pretty much the same like this human agent in your call center.
Human agent, right? I mean, that's how they're being called, I believe, right?
Yeah.
Typically in a service environment. So you already mentioned the word orchestration. I do want to walk together with you a little bit deeper, maybe not completely down. We'll see how far we get, but for our listeners, myself, to really understand what is happening. So maybe you want to do that. Maybe as a general rule, just take us by the hands. And maybe I want to start with asking at a little bit higher level. So now there is potential customers here listening or wherever they are, you go to them. Now, let's say persons, companies who are interested in APA themselves. At the highest possible level, what are the different options? So, of course, in the end, we'll talk about your option, but as a start, they could build something themselves, I guess. They could maybe use a framework. Do they exist? Do platforms exist? So, and then my specific question is, because in the end, I know that you offer a platform. So what are the different ways that a potential customer can go? And why do you suggest maybe a platform would be the preferred way of going?
Yes, good question. Maybe I start with a more simple example that maybe more listeners basically have seen in their real life. If you look at RAG, Retrieval Augmented Generation, RAG-based chatbots, they're everywhere. And they're good for if you use kind of these do it yourself frameworks. It's extremely tempting to create something, let's say, quick and easy for a proof of concept. And everybody is happy to say, okay, it works and it basically does the job and you can do a little bit of tweaking here and there. And then you go, okay, we've got problem X solved. And in a large, typically in these enterprise environments, you end up having, 20, 30 of these RAG-based chatbots. And all of a sudden you realize there is something like, call it RAG sprawl, for example. It's the equivalent of cluster sprawl from the infrastructure space. And that RAG sprawl is basically something like, okay, what frameworks actually do we use to build them? What versions of the underlying framework do we use? Which knowledge store do we use? Which index is that knowledge basically sitting in? Yeah? And what are the documents that you've put into that index? And what happens if one of these documents actually changes, but that document has been loaded into 20 different indices, etc. So at some point, it becomes truly challenging basically to have that overview. And that overview is not just for the sake of having an overview, but that's essential at some point for things like risk and compliance management at some point. Now, if you transfer that example into the agentic space, that problem multiplies because it is like you've got for a single process, you've got multiple agents. So you've got multiple configurations in terms of agent X is specialized in this and agent Y is specialized in this. And it's even more critical to have things like this kind of policies, etc., under control because these agents directly interact with the business process. So if you've got cluster sprawl on the infrastructure level, it is a bit painful because your infrastructure cost is too high. You need to pay people to just get it under control. But if you do things like agentic automation, you've got the immediate interaction in the business process, and there is no other line of defense, so to say. So what I'm saying is it's absolutely crucial for you as an organization to just fully have under control what these agents do, how they behave, and what the underlying, let's say, policies are that these agents have to adhere to. And if you come up with, let's say, 30 different agents that are based on your do-it-yourself Python framework, can do it. But in all of these 30 instances of these agents, you will manually have to create validation steps in between. So you're writing code, basically. And if you've got these 30 different agents operating and that underlying policies change, you would have to go through all of these single 30 Python scripts and adjust these policies. So at some point, for a handful of these DIY framework-based agents, it's good for exploration. It's cheap and easy just to find out whether it works or not. But if you want to move kind of near into production and kind of an operational day-to-day usage, you won't be a very happy man if you do it outside the platform approach, because at some point it becomes unmanageable, really because of this, let's say, the fragmentation of these different components that you use.
Okay, so I understand now. Why would I then go for your platform? And, maybe on the fly you can explain, because that's what I read somewhere. You have, maybe that's one of your USPs, maybe it's not the one. You have this embedded multi-agent orchestration engine. Is that the reason or one of the many reasons why to consider using your platform?
Well, let's say it's that orchestration engine that allows us to do things in a different way. And at the end, we're not selling agents as such. It is agents basically that you use, that you consume from us, agentic automation. But effectively what we're selling is that you can use agentic automation in a safe and a reliable way. And what I mean by that is that this engine that you mentioned, that is basically ensuring that in each of the single agentic interaction, so when these agents collaborate, and if agent 1 has finished his task and passes his, let's say, the partial result over to agent 2, the orchestration engine intercepts with each of these single communications, or its data packages, so to say, and validates that action. So basically the result from agent 1, which is the input for agent 2, validates each of these interactions between a set of rules and policies that you can maintain as the administrator. And that can be
Okay, and that's how they become safe and reliable, you say. So can you give us an example? That's whatever you think. I'm not sure that RAG is the best example because that everybody, but an example which maybe I assume more of us have, maybe stay with the repair request or something similar, but give us an example of these different stages and what then the orchestration does specifically.
So maybe I'll give you an example from the financial services space. It's the customer onboarding process. And as part of this customer onboarding, you, have to do 20 different things. And one of them is anti-money laundering validations. Yeah? And clearly you want to automate this, but the regulator, in German, the BaFin, basically kind of forces you to do it in a certain way and to ensure that different things have been done. So we talk about process controls. And basically, as a bank, you have to document that as part of this process, you have done certain things. And if you have, let's say, a DIY framework with agents like, say, okay, do customer onboarding, you kind of let them figure out to do it somehow. Now, chances are that they do it in a way that the regulator requires, but you cannot kind of guarantee it, if you know what I mean. And for these type of processes, and this kind of clearly when we go into, let's say, the industrial space, it's even more crucial because the potential damage is not, it becomes tangible if, production processes break or machines break or whatever. It's really essential that you're not doing this automation somehow, but you do it in a way that you can, as the administrator or even the, let's say, the managing director or the board of that company that uses automation, can guarantee and ensure that you adhere to these basic rules of your industry.
Now, as you already mentioned, and as we are the Industrial AI podcast, why don't we just jump into and see how your agentic platform can be used in an industrial environment. Now, not sure we want to start with that one. You can choose any other one, but you and I, we met at the Siemens AI for Purpose Summit couple of months back in Munich, you presented a use case with Merkle CAE that was called Sovereign Digital Intelligence for Strength and Flow Simulation. Is that where you want to maybe start? What can be done with agentic in an industrial environment?
Yeah, certainly. So let's say the challenge we were facing here is that the company, Merkle CAE, they've been in business now for over 20 years. And basically what they do is they offer finite element-based simulation and strength simulation and fluid dynamics, etc., for certain industrial parts, like turbocharger boxes and I don't know what else. And it starts with like that they've hundreds, thousands of projects report from past projects where they said, okay, it's customer, I don't know, Volkswagen, and they've had a turbocharging box with this material and this kind of, material parameters and this dimensions and this requirements, etc. And when it comes to this industrial simulation, I mean, obviously a lot of this knowledge in terms of what was the best optimized solution at the end is buried somewhere in these, like what were the initial design parameters and how did you organize this optimization during the finite element calculation process. Yeah? And that's pretty heavily reliant on the engineer who runs the simulation, clearly. And if you now have people that joined just 3 years ago, with a traditional enterprise search, they're not even nowhere near to be able to go through this historic projects to extract that sort of intelligence. What parameters did you use? What were the input? What was the output? And how did you best kind of organize this optimization in between? And this is where this type of agentic automation can deliver tremendous value because, for example, you go in and you give the system a description of what you want to simulate. What's the purpose of this?
What do? You write it down, take it by the hand. So exactly that. So he or she, just from university, maybe has been there has been onboarded into the company. And then, in week number 2, sits in front of a screen and has a first project and is doing then what? Is then writing it in, or maybe we come to that later. Maybe there's another way of interaction. But so is giving the system what it is that he or she wants to do.
Yeah, very good point. Yes. So the real breakthrough thing is that you just type it in natural language. So you just say, okay, I want to simulate this and that. And these are the specific parameters we need to take into account. And this is the result I want to get. So you just write plain, whatever, English, German. And then the system starts. He analyzes kind of this task. We use things like ontologies in the background to say, is there a specific material we need to consider? Is there, I don't know, a particular part or something, yeah? Or particular, is it temperature dependent simulation, etc. So like, let's say meter parameters. And then let's say something like a search agent starts working to say, okay, did we have similar cases in the past? Another search agent would just go through and say, what were the results of these projects? So what was the final design that came out? And then you've got some sort of analytic agents that basically start to interpret how did we get from A to B. And the result is that basically you get as an engineer that the system makes you a proposal on what parameters you should use as a starting point for your CAE simulation. So you're not starting from blank, no greenfield, so to say, but you've got a kind of an educated starting point, and the system kind of supports you.
Yeah, it sounds very much like, what word am I going to use? I can use whatever word I want, but co-pilot is one, I guess. But what I really mean is, so he or she, as I said, 3 weeks from university, sitting there, let's say, by themselves, but it's almost like imagining that this person, 50, 60 years old, has been in the company or in the industry for 20, 30, 40 years and is sitting next to you. And you would say, okay, what is my first job? Okay, fluid dynamics of whatever topic XYZ. And it feels like you're doing a discussion with the human next to you, which has 40 years experience. And that person will immediately tell you, okay, so you're going off to the left, but then is asking you a question. Well, but how about what happened? I mean, in the end, you need to know such and such. So it feels like you're giving, maybe it doesn't have to be a young, but an unexperienced person, you're giving through agentic approach the knowledge of an experienced person. Is that fair to say?
Yes, I think it's pretty much like a knowledge vault that sits underneath. Yeah, exactly.
Okay, so I quickly asked, like, what is, I mean, the suggestion was typing in. So, but let's talk about, I think at the very beginning you talked about large language models. Let's not forget them, or we could put agents already the next thing for the next year, I guess. But what if and what role do then large language models play in your agentic approach?
Yeah. So first of all, we use them to translate the initial user queries, so that plain text that we just talked about, to, let's say, translate that into the respective knowledge requests, so to say. And when we talk about using ontologies, we need to have a first call. Let's say, okay, what is the structure of that ontology? And the user input that he gave, plus the schema of that ontology, we give that to a language model and say, please, can you extract the relevant, are there any instances of that ontology in that user request? And if yes, which of them are relevant? So basically the language model returns something like an advanced search query, if you want to call it like this, for the first agent. And then the agent can do its work. So that's the first thing, which is kind of the, let's say, advanced, analytics, so to say.
Tell us quickly in between what the ontology is. Share with our listeners. Not everybody may know.
Okay, yes. So an ontology in a simple case may say, like, the material is one thing we want to consider. It's one essential thing for these type of simulations. So material would be some sort of a class. And under material, you can have, I'm not that sort of engineer, but you can have Eisenguss. I don't know what it's called.
Steel or wood or whatever, yeah. So.
Yeah, exactly. And you can have, like, is that simulation, is it temperature dependent, yes or no? Or is it, I don't know, any other aspects that are, it's like when you would run an expert interview with a human, this would be the typical expressions that person would say to say, you need to consider this and you need to consider that. And the ontology is a bit of an abstraction, a conceptual abstraction of these kind of human expert rules, the domain knowledge, so to say. So basically, language models are used for that initial step. And then if these, let's say, search agents and these analytic agents have done their job, then the language model are being used to interpret that and kind of translate it into the answer for the specific request. So they are like summarizing the search result with regards to the initial request, so to say. That's the second step.
Okay. And they do that in an autonomous way? I mean, how autonomous are your agents, or is it more like human in the loop? I understand the idea is that if you have what you call micro workers, I believe there's a registered trademark even I've seen. So if they do what you call the hard work in a person's everyday life, then, the person who we just talked about sitting there, they can concentrate on the important, maybe the more creative things, I believe what people say. So how is autonomy important or not? I mean, is that a part of agentic? How do you see that?
Yes. So basically, the core idea of our platform is you can make it as autonomous as you, as the human, want them to be or allow them to be. So you've got full control to say, like, for a start, I just want to have this kind of summarization and I just want to be given let's say, a proposal by the system. But then the human is still interacting with a finite element system in order to just type the stuff in. You could go one step further if you want and have some sort of, let's say, a function call, which you can configure in our platform. The function call basically would be an API level interaction with a finite element system, so that the single parameters that the system proposes could be automatically generated in that FE system.
Sounds like what I would like to do.
Yeah, well, and you could go one step further, Peter, and say, okay, finite element system, now do some 20 variations.
Yeah.
And autonomously run these 20 calculations on your own and comparing the results.
I mean, in the end, we stick with the young person from university sitting there in his or her third week. Maybe in the beginning they're allowed to play around, I guess, but at some point in time they're going to get a requirements list, right? They need to become productive in the company. So they're going to be part of a project. They're not going to take huge responsibility from the beginning, but nevertheless, there's a list of requirements that they receive one way or the other. There's a project on topic XYZ and it needs to do ABC, et cetera, et cetera, et cetera, the cost and the pressure and all these wonderful things for which then they are doing this simulation. So which maybe normally would take, I don't know, a couple of weeks before they get to do one or two simulations, could be, I don't know. I guess if they learn and understand that they can be seeing different simulations, and of course simulations on potential solutions that need to apply to the requirements, because all the other things are just, you don't want to necessarily look at things that are not going to work in the end. So in the end, is that going to make their job a lot more effective? Are they going to be able to come to a solution a lot quicker than they could without the agentic approach?
Yes, absolutely. And I would even add two more, so more productive, more effective. Yes. It gives you a different level of onboarding, much, much faster, because the system not only does something, but it also would give you an explanation why it did it. So you can use it as a kind of a, personalized teacher or something. But thirdly, and this is basically the bigger mission we're on, so to say, it allows that person to do things that the person itself could not do alone. So the combination of agentic and the human can do things in a volume and speed and complexity that humans alone, even if you had the best three talented engineers on Earth, they could just from a human brain power and capacity perspective could not do it. And what we want to enable is exactly this, to say, let's rethink value creation in the industrial domain and other domains. For example, if you take the GNOME project from DeepMind, I don't know if you heard this, they calculated just different crystal structures. So basically, when we use finite elements plus agentic automation, we could simulate thousands of these production processes, for example, to find new materials that include these new crystal structures. Or we could use it to, let's say, simulate industrial production processes that haven't been possible before. So it's not only about kind of productivity or effectiveness, but really we want to evangelize it to say humans and agentic automation that allows us to do things that just simply have not been possible yesterday. We want to be able to do them tomorrow as a kind of, let's say, almost as a foundation for a new sort of innovation and value creation in the industrial domain.
That the example you gave there sounds like for which Demis Hassabis, together with his colleague John Jumper, we just talked about it, and that's now a couple of weeks back now when we air our podcast, but for which they got the Nobel Prize for, in this case, chemistry, right? Because it was the AlphaFold. I believe it's about new proteins and about understanding the structure of the proteins. I have no idea about chemistry, but that sounds like very similar that you give in our engineering space as an example, and you could do it in other areas, a way to be doing things, as you say, that normally they could not have, no way in their life could have done just by themselves.
Exactly. And just to be clear, Peter, we would not have agents to do AlphaFold, yeah? But we use AlphaFold as a starting point, or the GNOME project with the crystal structures, to then do things that humans alone would just from a pure capacity perspective not be able to do.
Okay, let's come one step back again to the LLMs. I understand you are LLM agnostic. We're not going to go into the details of the LLMs this time, although they are, of course, very important. And somewhere I also read about understanding, which is an interesting topic. But tell us a little bit about the large language models that maybe you provide, or you are agnostic and you say, well, you customer, you can decide whatever large language model you put, is it correct to say, in front of the agentic system?
Yes, I think we would use the term just plug it in. So from an LLM viewpoint, it's agnostic in terms of you can pretty much use any LLM that is out on the market. However, it's clear that it would need a certain level of, let's say, able to handle a certain level of complexity. So a 1B or 3B model probably would not work in combination with different domains. But we have something like, it's similar like unit tests from the software development. You can have, as a customer, you define, let's say, some sort of golden source rules and trunk truth. And you would have like the language model initially pass a certain level of test just to make sure that the domain capacity of complexity the model is able to handle, that this is kind of adequate for the particular domain you look into. But other than that, you pretty much can go with your GPT class of model, Llama class of models, Mistral class of models, whatever.
And if the customer doesn't bring their own, then you will provide them with one of your preferred models that you work with?
Well, yes. I mean, as an administrator on the platform, you can just onboard. It has a model registry. You can basically just activate new models, so to say, in terms of the platform. And you can then allocate any model pretty much you want to that agent, to that particular agent. You can run these sort of tests and just make sure that the quality of output is satisfying.
Right. So tell us about the training of these models. So if I'm in this, simulation, fluid dynamics simulation environment, or I am in a, building what kind of mechanical machine production line, anything that I can imagine in our industrial environment, I need to train that model with, my company knowledge, with my market knowledge. Robert and I have talked now for years about industrial foundation models, so to say. Is that necessary, or at least is it necessary? We talk about the CAE that I think you say 20 years of experience. So you need to provide the information of these 20 years, as an example, into some kind of database ontology. How does that work?
Yes. I mean, for that particular domains, we would semi-manually create some sort of ontologies. For some domains, we already have, let's say, pre-configured ontologies, but that's not kind of training as such. This is more like kind of human level expert interview, and then having somebody to define like the basic schema of that ontology. And if that basic schema is defined, so the classes and the potential instances of objects, you can certainly use LLM to synthesize additional classes, etc. But from a customer viewpoint, we would not need to use its data, his or her data, to do a classical training in that term. So that's that data, that particular data, sometimes it's IP relevant, that stays completely with the customer. And let's say the translation in a way, or the customization for that particular domain, that is handled by the ontology at the end.
Okay, and that comes from general market information, or you detract it from the customer's information that they have available in wherever it sits?
Yes, most of the time it's a combination, to be honest. So we have some general ontologies from domain knowledge, but you can clearly enrich that for your particular domain.
Right, because it sounds like what you do with federated learning. What is the famous quote? It says like, you don't bring your data outside of your premises to the algorithms, which are somewhere in the cloud, but the algorithm comes to your data and extracts the information. Is that a way to think of it? So you say because the data stays with the customer, but still you maybe every now and then it's useful to at least extract important information, knowledge. Again, that is the knowledge of the person that is not sitting next to you with the 40-year experience. So you do want to somehow extract that information almost of the brain of that person, but it's not in the brain. So you want to extract it somewhere from the information that resides somewhere with the company, or?
Yes. And clearly when it comes to the LLM usage, I mean, clearly you'll have to send part of this information to the LLM in order to interpret it, to let the LLM interpret it. But when it comes to selecting LLM providers, we only choose those who are at least contractually guaranteeing that these LLMs operate stateless, which is effectively you just send data in, you just get data out, but it's not going to be stored for logging purposes, and certainly not for retraining models, etc.
Okay, and then there's this not always so nice topic about operating on the European market, with some of big tech not sharing their latest, greatest models with us. Share with us maybe an overview of your tools, technologies, providers, and how you go about, deciding who you want to work with.
Mm-hmm. So at our current state of things, we have come to a point with the platform, in combination with these ontologies and the approach we just talked about, that we can run at least all of these use cases we've been doing so far in combination with the GPT-4, Mistral 2, and Llama 3.1 class of models. 70B, certainly the 405B model from Llama. So our approach, like without LLMs, the thing doesn't work. That's absolutely clear. Yeah. But for us, the LLM is not the center of the universe, and we're not looking to get always bigger and more powerful models. But pretty much from a strategic viewpoint, I would say we have come to a point where we've got enough models that are powerful enough that in combination with the rest of our system is able to handle that stuff that we need.
And new, smaller models are more capable than, I think we said a couple of weeks ago, there was the example of 180th bigger. Was it 180 billion model? And now there's a 1 billion model, and the latter is more capable. So there's, of course, a lot of development there. Now, tell us a little bit about your team. Where you're based? You're looking for colleagues or not? Or if so, what should they bring?
Yes, we just relocated from Kaiserslautern to Karlsruhe because we've been, Karlsruhe offers a great network, offers a great talent pool. We've got a lot of customers in Baden-Württemberg, effectively. We've got a second location in Mannheim, which is close enough. Got a people just living in Mannheim.
For the international listeners, Baden-Württemberg is the area where most of German industrial machine manufacturing companies are based. Is that right?
Yes.
So not only companies which most of us have known, let's say the most important one that everybody around the world knows. Mercedes is based in what you said, Baden-Württemberg. They're from Stuttgart, I believe, right? Or close to Stuttgart. Oh, I need to be careful here.
Yes. I think pretty much those what you call these hidden champions in the industrial space.
Exactly.
Maybe not all of them in Baden-Württemberg. Certainly.
So tell us about your team. You are the owner, the driver. You started it. Who are your colleagues? What do they do typically?
Yes, so we basically got two larger teams and a third team which is a bit smaller. The third team is just business management and anything related to non-technical stuff. And from a technical side, we've got a team that we call knowledge engineering. So they are still tech people, but more kind of the type of data scientist, prompt engineer, etc. So they work basically on ontologies and just getting stuff domain specific and basically configuration. And then we got a platform team, which is the DevOps, the people who just basically write the code for our services, including the infrastructure team. And then clearly from now on, we're looking, probably, I would say from the next 6 weeks, towards end of this year, clearly beginning of next year, we are looking just to just get the market entry, so to say. We've been still in the early days. We're not yet stealth anymore, but we didn't really take it big, so to say. But that's clearly something that will come for, towards end of Q1, I believe.
Just to come to a close, give us an idea how the world is going to be looking different than as soon as you have had the opportunity to enter it with your solution, with your platform. Of course, we cannot really look into and say what's going to be 5 years, but what's going to be happening in these next 1, 2, 3, 4, 5 years? What is APA? What are AI agents going to be doing to, of course, the change processes that we talked, but more specifically for us listeners in our industrial design, engineering, and production market specifically?
Very good question. So I think, if you look at Europe in full right now, things are too slow. They are clearly far too complex in far too many spaces. And the not productive overhead, when I look at the industrial space, which is like the core value generation, that the ratio between the overhead and the core value generation has become poor. So in 2-3 years, whatever, what I personally think agentic automation will give us is, first of all, when it comes to bureaucracy, etc., that we're going to speed things up, and not just by 10%, but by factor X. So things when you apply for, in the government space, you want to have a new industrial process or building something new. I want to turn around the thing to say you're not sending something in, an application for something, for a permission, but the system just automatically just pushes it out to the person who's supposed to approve it and gives it all the necessary context. And if there is nothing in it that would contradict the permission's being set. My vision is to say, do it 10 times X faster, not just 10%. Secondly, we want to give, particularly in the industrial space, we want to give people tools that they can, as I mentioned with this example, with this simulation space, we want to create new tools that in combination with humans, we can do things that simply haven't been possible before. And if we do this in a larger scale, then we can have a whole new type of innovation where you say, let's come back, let's reinvent invention, so to say, which is to say, the stuff that happened the last 20, 30 years was just incremental improvements here and there. Somewhere there was groundbreaking innovation, but I think time has come where this incremental improvements isn't just getting us fast enough to where we need to be. So we need to kind of do different things in a different way. And I think agentic automation, because that the combination of speed and complexity and capacity. I wouldn't say it's not endless, but it's giving us capacity far beyond the human capacity. This combination can allow us to do new things, new materials, maybe new drugs in the medical space, the AlphaFold stuff, and new processes and new, the whole green tech, the whole, fintech, etc. So let's just reinvent these industries in terms of have a new sort of value creation, which is a hybrid of humans and sort of agent-based systems. That's my best vision, I would say. This is basically why we get up in the morning, to just, play our part in terms of enabling this scenario.
Amazing. You seem to be very much in sync with the people from the Nobel Prize that have decided at least to give AI their prize in the areas of chemistry and physics. Not sure about the other ones, I haven't heard, but they're going to be there as well sometime. Christian, thank you very much. You took us by the hand, starting from BPA. We talked about RPA, moving towards APA, Agentic Process Automation. Thank you for sharing the view on what's going to happen. So that was a new thought to me. So you want to use also the agentic approach to take care of specifically I think if you're going to look worldwide, probably Europe, but we should be honest, most especially probably German public problem of bureaucratic overhead. And you say you want to be able to do things 10 times faster, and that way you want to facilitate new things. So thank you very much for sharing your thoughts there. If there is any listeners that want to get in touch with you, they best do that through LinkedIn. We'll put your name in the podcast notification. Otherwise, if you, dear listener, have any question, comment, as always, please send a short email to me, peter@aipod.de. Very happy that you stayed with us. Looking forward to have you with us again. And Christian, thank you very much for your time and your great approach towards agentic AI.
Yes, thanks, Peter. Thanks, everybody, for listening. It was a pleasure to be able to share these thoughts.
Thank you. Bye-bye.
Bye.